You write a small function to grab the first item of an array. For strings, it takes a string array and returns a string. Useful. But now you need the same thing for numbers. So you copy it and change string to number. Twice the code for one idea. Tomorrow it is booleans. Then your own types. This does not scale. Notice the body never changed. Only the type did. So make the type the variable. Here is that same function written just once. T is a type variable, a placeholder for a type you will choose later. Pass an array of strings and T becomes string. A string goes in. A string comes out. The type is kept. Pass numbers and the very same function makes T a number. One definition, every type, and the type is never lost. And you rarely write the T yourself. Call first with strings. TypeScript infers it. A is a string. Call it with numbers instead. N is a number, no annotations and full safety. The argument decides T. You just call the function. Now, the lazy way you might be tempted to reach for, any, compiles, strings, numbers, anything goes in. But look what comes out, any, not string. The type is gone, and with it, autocomplete and the safety. Numbers, the same story, in as a number, out as any. Generics keep the type, any throws it away. That is the whole difference. And here is the part that surprises people. You have been using generics already. An array of strings is array of string. Promise of a user, a map from string to number. Those angle brackets you have typed for months, generics the whole time. The only new step is writing your own instead of just using theirs. Some generics carry more than one type variable. Take a map function. It transforms every item of an array. Give it numbers and a function that turns each number into a string. T is the input type. Here, number. U is the output type. Here, string. So out comes an array of strings. Two variables let the types differ while staying connected. Sometimes T should not be allowed to be just anything. So constrain it. T extends something with a length. Now, inside you can safely read .length. Strings have a length. Arrays have a length. Both are fine. But a plain number has no length. So this call is rejected before it ever runs. So, the mental model for generics. A generic is a type variable. It binds to whatever type you pass in. And it preserves that type all the way through instead of losing it to any. Constraints let you require what T must have. Write it once, keep the types, and let the caller fill in the blank.